to the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
My wonderful viewers, listeners, and learners at home, you're welcome once again to the Ministry of Education, Kaduna State Radio, TV, e-learning program. My name is Mr. Philip Maman, your chemistry teacher. And on chemistry today, we'll be looking at organic chemistry, another aspect of organic chemistry known as the alkanols. Previously, we have discussed hydrocarbons and all the homologous series that are under the hydrocarbons. Today we'll be going further to look at another homologous series that is not a hydrocarbon, meaning that it contains elements other than carbon and hydrogen. And under the alkanols, we'll be looking at introduction, sources of hydrocarbon, nomenclature and structure, classification of alkanols, method of preparation of alkanols, properties of alkanols, and of course, uses of alkanols. This lesson will be in two series. So we are taking the first part today, and we will conclude the last part as we'll be talking about tests of alkanol. When we say alkanols in chemistry, they were formerly called alcohol. I'm sure if I had said alcohol at the beginning of my lesson, what will come to your mind is those substances people take to get intoxicated. In chemistry, alkanols goes beyond the materials that are taken. We'll be looking at it as a homologous series today. Alkanol, formerly called alcohol, are organic compounds that contain carbon, hydrogen, and oxygen. They are formed when an hydroxy group, OH, get linked to an alkyl group. All alkanol contain at least one hydroxy group, that is the OH, as a functional group. Now, what is a functional group? In our previous lessons, I have told you that a functional group is a group of atoms, bonds, that determines the chemical property of an organic compound. So, the functional group of the alkanol is the OH. They have a general molecular formula represented by CN, H2N, plus 1 OH, where the N is a whole number, such that the first member has N equal to 1, the second member has N equal to 2, and if you substitute in that molecular formula, you will come across the various members of this homologous series. A summary of it here includes the name, molecular formula of an alkane, because the difference between alkane and alkanol is removing the E in alkane and replacing with an OL, which makes methane becomes methanol, which makes methane becomes methanol, which makes ethane becomes ethanol. So in the names of the alkene, you remove the last E and replace it with an OL. So methane is methanol, ethane is ethanol, propane is propanol, butane is butanol, pentane is pentanol. But let's look at how you can come about it. Now, methane has a formula of, alkane has a formula of CN, H2N plus 2. So you can get a CH4 to be methane. If you remove one H from an alkane, you have an alkyl group. An alkyl group is CH3, and that is methyl. Then you have ethyl, propyl, butyl, and pentyl. What is the molecular formula of alkyl? Is CN, H2N plus 1, meaning that when you remove one H for an alkane, you will get an alkyl group. Then you have corresponding methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol, nonanol, and decanol from 1 to 10. These are the first 10 members of the alkanol family. If you substitute your values in the equation I have given you as CN, H2N plus 1 OH, if you put 1 as N, it becomes C1, 2 times 1 is 2, plus 1 makes it 3, then OH, you have CH3OH for methanol. If you substitute 2, which is the second member, you have C2, 2 times 2 is 4, plus 1 is 5, so you have C2H5OH, which is ethanol. And you will continue in that order until you get the desired member that you want. For instance, if you want the fifth member, you replace N with 5. It becomes C5. 5 times 2 is 10, plus 1 is 11 OH. That is what you have here, C5H11OH. And that is that on the the various molecular formula of the alkanol members. It can be seen that the alkanols are formed by simply attaching the hydroxy group OH to an alkyl group, as we have seen previously, while the alkyl groups are formed by removing an atom from hydrogen, that I have mentioned also previously, from each of the alkane members. This process of removing hydrogen from the alkane member to form alkyl group is called dehydrogenation. The process of removing hydrogen from an alkane to form alkyl group is called dehydrogenation. Now, classification of alkanol. We classify alkanol based on the number of OH they can carry. In my introduction, remember I told you that an alkanol can contain at least one OH, meaning that it can contain one and above OHs. So, if it contains one OH, it is called a monohydric alkanol. But if it contains more than one OH, it becomes a polyhydric alkanols. So, we have monohydric alkanol and polyhydric alkanol, depending on the number of OHs. If it's only one OH, it is a monohydric alkanol. If it contains more than one OH, it is a polyhydric alkanol. Monohydric alkanol can be classified into primary, which is also called first degree alkanol, or secondary, which is called second degree alkanol, or tertiary, which is also called third degree alkanol. Remember I said monohydric alkanols have one OH, and they can further be divided into primary, secondary, and tertiary alkanol, or first degree, second degree, and third degree alkanol. Example of a primary alkanol is ethanol. Secondary alkanol is propan-1-ol. And of course, tertiary alkanol is 2-methyl-propan-2-ol. Now take that again. Example of primary alkanol is ethanol. Example of secondary alkanol is propan-2-ol. And example of tertiary alkanol is 2-methyl-propan-2-ol. Remember, secondary alkanol example is propan-2-ol. Now let's look at polyhydric alkanol. Polyhydric alkanol can be divided into dihydric and trihydric alkanol, meaning that dihydric means have two OH in one alkanol compound. So let's look at example, ethane 1,2-diol, meaning that there is an OH group on carbon number 1 and there's another OH group on carbon number 2. And that's why it is called ethane 1,2-diol. The di there tells you that there are two OHs. And the ol here is standing for the functional group. Then what about trihydric alkanol? We have example as propan-1,2,3-triol. That is the IUPAC nomenclature of glycerol. If you use glycerol in your houses, you know that that is the IUPAC nomenclature of glycerol. Now, let's look at the type of monohydric alkanols. These are alkanols with only one hydroxy group, OH, in their molecule. The first member of the family are methanol, CH3OH, commonly known as wood spirit. Ethanol, CH3, CH2OH, or C2H5OH. Then we have propanol, which is CH3, CH2, CH2OH, or C3H7OH. Methanol, or wood spirit, is obtained by the destructive distillation of wood. Other example of it is, you can see the structure of ethanol, 2 carbon atom bonded, and each of them is bonded with 3 hydrogen and an OH group. Then what about propan-2-ol? You can see that the OH is on carbon number 2 out of the 3 carbons. So that is why it is called propan-2-ol. Now, having said that, let's look at polyhydric alkanols. Polyhydric alkanol, remember I said the number of OHs are 2, as you can see here. Ethane 1,2-diol. You can see the OH is on carbon number 1 and on carbon number 2. Consequently, the name is ethane 1,2-diol. Then we have propan 1,2,3-triol. You can see the OH on carbon number 1, the OH on carbon number 2, and the OH on carbon number 3. That is why it is called propan 1,2,3-triol or propane 1,2,3-triol, as the case might be. Now let's look at the other classification. Monohydric alkanols can also be classified into primary, like I said earlier on, first-degree alkanols, secondary, second-degree alkanols, tertiary, third-degree alkanols. Now, what are primary alkanols? Primary alkanols, in this group, the carbon bearing the OH, meaning that the carbon atom that is carrying the OH is in turn bonded to one alkyl group. It's in turn bonded to one alkyl group. In other words, the carbon atom that is carrying the OH group is bonded to one other carbon atom. Or you can say the carbon atom that is carrying the OH group is bonded to only 2 hydrogen atoms. And that is why you can identify a primary alkanol. Now, what about the secondary alkanol? In the secondary alkanol, you find out that the carbon atom which is carrying the OH group is in the middle, and it is bonded to 2 other alkyl groups, both in the front and at the back. Is bonded to 2 other alkyl groups, or in other words, is bonded to 2 other carbon atoms, or is bonded to 1 hydrogen atom, meaning that the carbon atom with OH group is bonded to 1 hydrogen atom, or the carbon atom with the OH group is bonded to 2 alkyl groups, or the carbon atom with the OH group is bonded to 2 other carbon atoms. No matter how you understand it, you'll be able to understand what we mean by a secondary alkanol. The last one is tertiary alkanol. In the tertiary alkanol, the carbon atom that is carrying the OH group, as you can see here, is bonded to 3 carbons, 1, 2, and 3, or is bonded to 3 alkyl groups, 1, 2, and 3, or in other words, is bonded to no hydrogen atom. You see that in tertiary alkanol, the carbon atom with the OH group is not bonded to any hydrogen atoms. So that's how you can identify your tertiary alkanol as 2-methyl propan 2-ol as we proceed. Now we are coming to a very interesting aspect of alkanol, which is the IUPAC nomenclature of alkanols. Now this IUPAC nomenclature simply means the IUPAC system of naming alkanol. What is IUPAC? IUPAC stands for International Union of Pure and Applied Chemistry. So when we say IUPAC nomenclature, we mean International Union of Pure and Applied Chemistry system of naming alkanols. Now, in naming alkanols, the following rules must be observed. Number 1 rule, longest chain rule. It means that you should identify the longest chain with the OH group. Now, the longest chain means the highest connected carbon atoms. So it says, identify the longest chain with the OH group connected and give it the parent name. It means that if the longest chain is 1 carbon atom, the parent name becomes methanol. If it is 2, it becomes ethanol. If it is 3, it becomes propanol, and so on and so forth. Then number 2, it says that alphabetical order rule, substituent, alkyl group or branch are arranged in order of increasing alphabet, meaning that E comes before M. So if you have ethyl and methyl in the same structure, when naming, ethyl should come before methyl. Then the comma and hyphen rule, meaning that numbers are separated by a comma. If you have 2 numbers in the name, they are separated by a comma. While a number and alphabet is separated by a hyphen. That means if you have a number or a number preceded by an alphabet, you introduce a hyphen. My wonderful students, haven't heard what I have said earlier, that we have about 4 rules that we will consider. The first one is the longest chain rule. And like I said, identify the longest chain, meaning that the highest connected carbon atom, and give it the parent name. Remember I said that if there are 5 carbon atoms that are the highest, it becomes pentanol. Then the second rule is numbering rule. Numbering rule is done in such a way that the functional group, in this case OH, is given the lowest number. Numbering is done in such a way that the functional group, which is OH, is given the lowest number. Then we have the next one, which is alphabetical order rule. That alkyl group, when there are more than one alkyl group in a compound, should be arranged in order of increasing alphabet. Meaning that if there is methyl and ethyl, E comes before M. So ethyl should be named first before methyl. Then the last one is your comma and hyphen rule. Numbers are separated by a comma. Then number and alphabet is separated by a hyphen. Now let's look at this example quickly. You can see that the longest chain here is 5 carbon atoms. So the longest chain is 5 carbon atoms, and the OH is on carbon number 2. And the OH is on carbon number 2. The alkyl group on carbon number 3 is ethyl. And the alkyl group on carbon number 2 is methyl. So you can see the name is, the longest chain is pentan-2-ol. Why is it pentan-2-ol? Because the longest chain is 5 carbon atom. 2-ol means that the OH group is on carbon number 2. Then we have 3-ethyl because E comes before M. So ethyl group on carbon number 3. Remember, there is an ethyl group on carbon number 3 that has 2 carbon atoms with 5 hydrogens attached to the 3rd carbon atom. Then there is a methyl group that has 1 carbon atom and 3 hydrogens attached to carbon number 2. So the complete name becomes 3-ethyl, 2-methyl, pentan-2-ol. That's the correct name for this compound. I'll take it again. 3-ethyl, 2-methyl, pentan-2-ol. I'll take the next example and you follow me as I'll take it gradually again. Remember I said identify the longest chain. The longest chain means the highest connected carbon atom. If you count all round, you find out that the highest connected carbon atom is 7. And if you look at it, 7 is heptanol, heptanol, heptanol. Then we find where is the position of the OH group. The OH group, which is the functional group, is on carbon number 4. So the name becomes heptan-4-ol. The name becomes what? Heptan-4-ol. But if you look at the compound, on carbon number 5, there are 2 alkyl groups. That's 2 methyl group on carbon number 5. There are 2 methyl group on carbon number 5. Remember I said your methyl group is CH3, and there's another CH3 on carbon number 5. So the name becomes 5,5-dimethyl heptan-4-ol. The name becomes 5, comma, because I said in between 2 numbers there's usually a comma. Then 5-dimethyl heptan-4-ol. That is the name of this compound. My wonderful students, when you lay your hands on several other materials, you find so many examples. Try to name these organic compounds, and please get back to me to know whether you have done the right thing or not. Remember, if there is more than one, if there are 2 OHs on the compound, it is a diol. If there are 3 OHs, it's a triol. So remember that you always interuse these terms when they are appropriate. I will leave you with this assignment to see if you have learned. Actually, the assignment goes thus. Give the IUPAC nomenclature of the following compound. The first one is CH3, CH2, C, open bracket, CH3, 2. Then we have CH2, CHOH, and CH3. I will explain this assignment again. Now, if you look at number 1, in the 3rd carbon atom, there is a CH3 in a bracket with a 2. It means that that CH3 is a branch. That means there will be one CH3 at the top instead of hydrogen, and there's one CH3 at the bottom instead of hydrogen. And maybe when you expand it, you understand what I'm saying better. So I'll say again, number 1 is CH3, CH2, C, open bracket, CH3, close bracket 2, CH2, CH, OH, and CH3. That's the first assignment. Number 2 says CH3, CH2, then CH2, open bracket, close bracket 4. Now look at that CH2. It means that this CH2 should be repeated 4 times on the ring. That will make the longest chain. Then we have CH, CH3. That CH3 is replacing one of the hydrogen in that carbon atoms. And of course, CH2, OH. I'll take that again. CH3, CH2, then CH2, open bracket, close bracket 4, CH3, CH2, so CH3, CH2, OH. Lastly, I'll take that number again. CH3, CH2, open bracket, close bracket, CH2, 4, then CH, open bracket, CH3, close bracket, CH2, OH. Then the last assignment is number 3 now, CH3, CH2, CHOH, CH2, CH2OH. I'll take that lastly. CH3, CH2, CHOH, CH2, CH2OH. If you look closely, you know that it's a diol. I hope you play around with this assignment and please get back to me to ensure that you have actually learned. I have had a swell time discussing chemistry with you this beautiful day. I hope that you follow your reference material, Understanding Chemistry by Godwin Ojokuku, New School Chemistry by Oshao Yao Ababio, and the last one is Stand Chemistry from Science Teachers Association of Nigeria. My name is your regular chemistry teacher, Mr. Philip Mamman. You can always get me on my phone number 08026598861. I'll take that again. Mr. Philip Mamman on 08026598861. For my listeners at home, you have to pay real good attention to grasp this topic because it's a topic that has to do with pictures and photographs. I hope those that have seen me through the television will do better. But if you listen attentively, I'm sure you'll be able to understand what we have said. In case you have any issues, you can follow me on this number on WhatsApp and then we can discuss properly. Have a wonderful day. Stay safe. Keep learning. Keep reading. And I hope to see you some other time. Have a good day.